a system of linear inequalities. Remember, just like a system of equations, a system has two or more. So a system of linear inequalities is two or more linear inequalities. For the purposes of Math 1, it's just going to be two inequalities most of the time. All right, and they're going to be graphed together. So the solution of a system of inequality, the solution is the overlapping region of points that satisfies both inequalities. So it has to be a point that makes both inequalities true. So let's look at a couple examples here. All right, number 1 says, graph each system of linear inequalities to show all possible solutions. So we're going to graph one at a time. So let's look at the first equation here, or inequality. And it's got a y-intercept of -1. So I'm going to put a point here at -1. And I have a slope of -1 as well. So -1 over 1. So I'm going to go down 1, positive 1. Or up 1, back 1. Down 1, plus 1. And you can just keep doing that. Alright, so this one says greater than, so that means it's a dotted line. So I can just continue those dots and make it a dotted line. And this says greater than. So I'm just going to put a little arrow for now that shows greater than the top line. All right, I'm going to change colors and graph number, or the second one. So it's going to be -5. So 1, 2, 3, 4, 5. And then this one has a slope of 1 as well. So 1 over 1. So this is going to be up 1 over 1, up 1 over 1. And this one is also a dotted line. And this one says y less than, okay? Less than means below the line. So the area of possible solutions, so it says show all possible solutions. That's the area where they overlap. So it's going to be below the blue line and above the red line. So it's going to be this area over here mostly in quadrant 4. So I'm going to highlight this area here. And this is your possible solutions. Now you can see I have arrows on these inequalities, and that means that they continue. If we had a bigger graph, then we could put more points on it. But it's going to be all points in that area, and that's going to just continue on as big as that area gets bigger. All right, number 2. If I look at number 2, let's use 2 different colors again. So the first one says +7. So 1, 2, 3, 4, 5, 6, 7. I'm going to put my y-intercept there, and then a slope of 1/3. So up 1, 2, 1, 2, 3, or down and back 1, 2, 3. All right, again, this one is a dotted line, so I can just put some dots in there. And this one says less than, so I need less than. I'm going to draw this arrow to remind me that the first line is less than. All right, I'm going to look at the second inequality, +4. So I go 1, 2, 3, 4. And I have a slope of -1. So -1 over 1. So -1. Or I can go up and back. Up and all right, now this one says greater than or equal to. So the line underneath that tells me that this one is actually going to be a solid line. And greater than means above the line. Alright, so all possible solutions are going to be below the red line and above the blue line. So it's going to be in this area here. Now, the dotted line means that the points on the red line are not included in the solution. If I picked a point on the red line and plugged it into this, it's not going to be a true statement. But the points on the blue line, if I plugged it in, it will work. So just so you know, all the points that are in the shaded yellow area are solutions, and the points on the blue line are also solutions that's in that yellow region as well. All right, we're going to look at number 4. This one says x is less than -4. So this one looks just a little bit different. So first you have to know, what is that line of x at 4? So we're going to come over here on the x-axis and go 1, 2, 3, 4. So -4 is here, and this is going to be a dotted line. So 1, 2, 3, 4. I'm just going to have a vertical line that goes through x at -4. So every point on this line up through here has an x value that's -4. All right, and then the second equation, we're going to have to solve for that. So I'm going to change colors here. And we're going to solve for y. So again, I'm going to subtract 3x from both sides. And I'm going to cancel this and bring down my 2y. Here I'm going to bring down my inequality, less than or equal to. Again, I'm going to move my slope to the front, just because I like it in slope-intercept form. And I'm going to divide everything by 2. y. Now, I divided by a positive number, so nothing changes. The sign stays the same. So -3/2 x. And this becomes -1. So I've got a y-intercept of -1. And I've got a slope of -3/2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. All right, when I look at this, this has a line under it, so that means less than or equal to. And less than or equal to means it's shaded in this direction. All right, after I graphed my -4, I did not put arrows, so I want x less than -4. Less than means smaller than, so if I go this way, I'm getting bigger, and my x's are going positive. This way, it's going negative. So less than would be this direction. All right, so I need all values that make both inequalities true. So that's going to be everything below this red line and to the left of the blue line. So any point you pick in that shaded region will make both of those inequalities true. Just don't pick a point on the blue line. All right, number 5, if we look at the first one, we're going to have to solve for y. So I'm going to bring it down here and say 4x minus 5y greater than or equal to -35. And I'm going to subtract 4x from both sides. So I'm going to have -5y greater than or equal to -4x minus 35. Divide everything by -5. Y is, instead of greater than or equal to, remember, I'm dividing by a negative. When I divide by a negative, I have to switch the symbol. And this 2 negatives makes that a positive. And this becomes positive as well, so plus 7. All right, so we're going to say 1, 2, 3, 4, 5, 6, 7. Our y-intercept is graphed first. It should be on the y-axis. And then I have a slope of 4/5. or 4 over 5. So if I go up 4 and over 5, I'm going to be off the graph. So I'm going to come down 1, 2, 3, 4, and go back 1, 2, 3, 4, 5. All right, this has less than or equal to. So first thing I know is it's going to be a solid line. And less than or equal to means it's going to be shaded in this direction. So I'm just going to put arrows there to remind me that that goes down. All right, so let's look at the second one. It's already in slope-intercept, so I can go to -2. I can put a slope of -1 over 1. So again, I can go in both directions here. And this one is greater than, so this one's just going to be dotted. So I'm just going to continue my dotted line there. And then this one says greater than. So greater than is above the line. And if we look at this, we can see that we need below this line and above this line. We need all the points that make both of these inequalities true. So this would be what you need to do. All right, I want to show you something on the calculator here. So you can graph inequalities on your TI-84 or your emulator if you have one. The only thing is it doesn't recognize whether it's a dotted or a solid line. So you have to know based on the inequality what that is. But if you want to see some of these graphed on here, you can do that. All right, so if I want to graph y less than or equal to 4/5 x plus 7, I can go to y equals, and you have to arrow. You can see like I'm over here past the equal sign as far left as I can go, and I'm going to enter, and I want the one that's the below, the one that's on the bottom, because less than or equal to means on the bottom. So then I'm going to arrow over, and I'm going to type in 4/5. Well, all right, let's see. Sorry about that, I was pushing the wrong buttons. All right, so let's go over here and push less than. All right, there's my less than, and I need to come past the equal sign and do 4/5, so that's 4 divided by 5, and then x plus 7. And if you want to see what that looks like, you can hit graph. And you can see that here I put arrows to represent that it went below this blue line, so that would look like this as well. Their scale may be just a little bit different, but if you wanted to change the scale, just go to window and you can change the scale. You can see mine's at a 10 by 10. All right, so I want to graph the other inequality. So y, and again, it's going to still be a solid line, but it'll still graph greater than. So greater than is the one that's shaded to the top. And then if I come over here, I'm going to graph -x minus 2. And then I hit graph. And you can see, like it shaded both of those, but the part that's overlapped, the dark part, is the same part that I have shaded here. So the solution set is all the ones in yellow. So everything below the blue line is a solution for that inequality. Everything above the purple line is a solution for that inequality. But a solution that meets both of them, or is a solution for the system, is the part that's in the shaded region.